Hello, welcome to the second episode of Azure Community Enthusiast. My name is Nicholas, and I'll be with co-host with Kevin Green.
Hey folks, welcome back to episode 2. We've got a smashing lineup tonight for you, so hopefully everybody learns something new. I know I certainly will from both our speakers tonight. So over to Dwayne. Are you going first?
Yes. Let me share some screen. So just give me a minute. So give you a few minutes. Can you see my screen? I take it you can.
Yeah.
Yes.
Okay. So to stay up to date, you can just follow us on social media. You can find us through LinkedIn, Twitter. Now it's called X, YouTube, and Facebook group. And scan this for barcode if you want. And this is the agenda for today. So the first session we have in roughly a few minutes is Dwayne, who is a global principal cloud security lead at ABM. And he's an MVP. And he's going to discuss 5 ways to protect sensitive data and tie with Microsoft Purview Compliance Manager. And roughly around 8:40, Josh Duffey will be doing a session. And he's from Senior Cloud Advocate at Microsoft. And then we'll be closing roughly 9:45 or roughly, approximately. And the next episode will be on the 30th of this month. And you have 2 sessions coming up. So Azure Cloud and Spend, it's about money by Wim. Mafiams, sorry, I couldn't pronounce that name. And Explore the Benefits of Azure Virtual One by Jake Welch. So, so the first session will be presented is Dwayne. So, do you want to I'll stop my sharing screen. So you can introduce. I'll let Dwayne introduce himself after. So get
all right, thanks. Yep, I've got into StreamYard. It should be down there. Thanks. There we go. All right. Yes. Hello, everybody. And thank you to Kevin and Nicholas for asking me to present here today on 5 ways to protect sensitive data and personal identifiable information in Azure and Microsoft 365 with Microsoft Purview. My name is Dwayne Natwick. I'm actually no longer with Eviden as a global cloud security lead. I am now on my own as Captain Hyperscaler LLC, which I am creating my own certification training and consulting company. But up until the 1st of this month, I was a global cloud security lead for Eviden, a GSI for Microsoft, AWS, and Google. I am a Microsoft Security and Azure MVP and AWS Security and Identity Community Builder as well. And I author content and provide live training for learning providers and as a learning provider. I'm certified in many Azure Microsoft 365 roles, as well as CompTIA, ISC2, and AWS. Microsoft Certified Trainer, regional lead for that program. And I've also authored 3 exam guides for Microsoft security exams. So the SC 900, 300, and 100 exams. And you can certainly reach out to me and connect with me on my website, as well as my blog site and LinkedIn and the artist formerly known as Twitter. So let's jump into our agenda. So today we're going to talk about some strategies to secure and govern data in the cloud, how to protect data exposure and maintain compliance, knowing where your data is in the cloud, which is very important, especially if you're involved in GDPR and sovereignty of your data, understanding what data is sensitive, and again, like I said, maintaining sovereignty of your data based on privacy restrictions. So governing and securing your data in the cloud, it's really a 4-step process that you should go through. And it starts with knowing your data. And this is where I kind of start off pretty much any conversation that I have or any talk that I have, because if you are not properly preparing and planning and making a strong strategy around your cloud transformation or your governance of information within the cloud, you are going to create a lot of problems for yourself. So knowing your data, knowing where your data is, what kind of data you have is definitely the way where to start. If you don't, if you have public data mixed in with sensitive data and all of that within your private data centers or your within the public cloud, then properly separating that and classifying that becomes a difficult task. So know your data, know what data you're working with, know what what data you have that's sensitive, know what data that you have that's PII or PHI within your environment. Then you can move into determining ways and means to protect your data. And we're going to talk about each one of these steps and how we can do that within Microsoft here in a moment. Once we have everything classified and we have everything, have solutions in place to protect it, then we can put policies and different solutions in place to prevent data loss. And then ultimately, we then can govern over our data, make sure we're not losing our data, make sure our data is not being overexposed, make sure we are not oversharing our data, and make sure that our data is also being handled within areas that we can within areas that we know and can govern for GDPR, for different privacy rules, for different sovereignty rules, and all of those areas. So let's start with knowing your data. Know where your data is located. Planning and identifying is the important aspect of knowing your data. What data do I have? What data am I handling? Where is it being handled? And how is it going to be classified? Like I said at the beginning, I teach ISC2 courses, and one of the courses I've been teaching a lot of is the Certified in Governance, Risk, and Compliance course, which that is based upon the NIST risk management framework. And one of the key aspects of all of this particular framework is preparing and then also categorizing your data, working with your system owners, working with your information owners, and identifying what data and what information is on our systems, and then classifying it based on the CIA triad, which, if anybody doesn't know what the CIA triad is, it's confidentiality, integrity, and availability. Making sure that data that's private stays private, making sure that when it is used and when it's sent, that it maintains its integrity, that it was not altered, and then availability, making sure that when somebody needs and has to access that data, that they have the proper permission to access that data and that it is available to them at that time. We go through those categorizations to make sure we have proper controls in place and that we are classifying that data properly. And we can do things of that nature within Microsoft and then within Microsoft Purview, as well as we can also do it within like Azure policies to make sure that certain data we have privacy risk management or PRIVA in Microsoft Purview. We have data classification capabilities within Microsoft Purview, as well as within like Azure SQL database capabilities. And then also information protection capabilities with sensitivity labels that identify that sensitive data so that we can build sensitivity policies in place if that data is handled by the wrong people. And understanding, again, how that data is sensitive and what makes that data sensitive is how we then take that a step further to protecting our data. We protect our data by creating that label for the sensitive data, applying encryption to it, both at rest as well as in transit, restricting access to that data, providing watermarks, and also then putting different sensitivity labels or data loss prevention policies in place that also make sure that that data is not lost. So how, that is, this is a process, and as we know where our data is, we can then start to protect it by utilizing these tools such as sensitivity labels and data loss prevention. We can put watermarks that say, classified or confidential, so that if a legitimate user opens up that data, they know what is being done. And they know what that data is classified, so they know not to share it. And again, we can restrict access or encrypt that access, so that if somebody without the permissions to access it cannot see that data. And this is a capability that we can put on all of our critical documents within SharePoint and OneDrive, with documents that we share in Teams, as well as documents and information within our Azure storage, our Azure SQL databases, as well as E3 buckets, which is the equivalent, for those of you that aren't familiar with AWS, as a storage account within Azure. So once we have done protecting your data, now we need to prevent that data loss. So protecting data exposure and maintaining that level of compliance, especially if we are dealing with PII, we're dealing with HIPAA regulations. We can detect risky behavior and prevent that accidental sharing of data using things such as data loss prevention, information barriers, and insider risk management are all capabilities within the compliance and within Microsoft Purview compliance to protect those areas. And we'll look at one of these. We'll look at data loss prevention in particular here in a moment, and show how we can set up that data loss prevention policy within our Microsoft Purview for different types of locations. The other piece here is maintaining sovereignty of data. So, if we want to govern our data, we want to make sure that we are utilizing data, and we have our data being maintained within certain jurisdictions. If we have to adhere to certain regulatory or governmental policies like GDPR, France has some very strict sovereignty laws. So does Germany. We need to make sure that data that is created within those geographical boundaries do not exfiltrate those specific boundaries either, or they do not leak over into other countries and cause a potential sovereignty issue. So we need to make sure that we're putting things in place to adhere to those capabilities, and that we're storing and retaining and deleting based on various levels of compliance as well. And within, again, Microsoft Purview, we have solutions such as, again, information barriers. We can create in our Azure storage accounts data lifecycle management. We can have retention labels, and we can have records management to identify that critical data, especially critical data to our business, that we need to retain, and we need to make sure, again, to adhere to the integrity of our contracts, of our financial information, by marking these as records and having a constant audit flow to how that data is handled, and how it then and really a custodianship to how that data continues to be utilized. And ultimately, this is going to improve and give us ways to verify our data security posture. So we can utilize Microsoft Purview, Azure Policy, and all of those tools within the Microsoft Cloud to provide a centralized and automated way to discover our data, to understand where potential data sprawl is, and increase our security posture across all of our cloud services. One of the nice things that around Microsoft Purview and Azure is things like Microsoft Defender for cloud and Microsoft Sentinel and Microsoft Purview all have connections within the Microsoft cloud, as well as connections where you can bring in other multi-cloud solutions like AWS or Google, or utilize Azure Arc to tie in on-premises devices as storage devices as well, and minimize then the potential for sensitive data exposure and support zero trust principles. We want to make sure that we are verifying everything, making sure our confidentiality, integrity, and availability all come through within zero trust to understand and discover our data, know our user permissions, verify our user permissions, verify our segmentation of our data from public to private, and having policies for least privilege and least and the least amount of access to reduce again potential attack surface and exposure, and data security posture management is becoming a very popular aspect to the overall security posture of the cloud, because we want to make sure we are supporting compliance goals, and Microsoft Purview provides that, and provides a level of automated data discovery, policy enforcement, and reporting. It also has various regulatory frameworks around GDPR, PCI DSS, and HIPAA, as well as, again, I mentioned Microsoft Defender for Cloud, and using the extended capabilities of Microsoft Defender for Cloud to help to understand where our data is and what it's doing. So to circle back, and we'll go really quick into, let me just pull up really quick and show how this can be done, and how we can take a simple categorization, in terms of our industry, and look at that and build a data loss prevention policy. And let me zoom in a little bit just for everybody to be able to see a little bit better. So we're going to look here at a particular category, and let's look at medical and health. Let's look at UK Access to Medical Reports Act. Okay. And so we're going to select that. You can see it's looking for health insurance numbers and health service number. So we're going to take that, and we're going to just select next. We'll just keep the standard name for our DLP policy here. We've got our administrator units. So this is where we would assign the policy to. So if I looked at our administrative units, I only have a help desk team in here right now to add. So we'll go ahead and do that, and we'll just do save. And then we select, and you can see here we have various devices in here and various areas. So we have Defender for cloud apps. I don't have all of my role groups set up in here, but you can see we have on-premises repositories we can connect to. We have different devices. We have Teams and chat messages, Outlook, Exchange email. We can, again, Defender for cloud apps will help us tie into access to different apps, even applications that we have registered within Azure. Again, the on-premises repositories also go in here as well. We can utilize and select and protect all of these different workspaces. And so we'll just select next. We've got the policy settings here, and we can then edit our policy mode of what information to protect and set it at a confidence level. The instance count can be set to anywhere. We can set it at one instance, or we can set it to we can set it up to however many instances. This is the amount of where we're going to get the alerts around our sensitivity labels. All right, and around the access to possible data loss prevention. So it's going to see that we've shared it multiple times. if we share it 1 to 9 times, it's going to give us an alert. If we go next, we can give the particular protection actions. We can restrict access or encrypt the content. We can show policy tips. So if a user has chosen one of these pieces of information and is about to share it, it's going to give a tip of around the piece of information and what might be the that you might be sharing sensitive information, and there might be some repercussions to that. So that's what that is, and we can detect when specific amounts of data is being shared at one time, or at least 10 or more instances of the same information type. So we can set this, take this down to, as soon as one piece is shared, we can alert and send an incident report, or we can, or if we want to make sure that this isn't going like on a blast message, I would ultimately recommend putting this at 1 at first, just to see if sensitive information is being shared and if there is a training requirement within our organization. We can then again select that. We can again select to block only people outside the organization, block everyone, require business justification if this is being shared outside the organization. So we can actually take this piece of these types of documents, make sure that these types of documents aren't going outside of our organization through this policy, or again, we can put those tips on to avoid that. Again, we can audit the restriction activities, upload that to certain areas. We can check the file activities for all of our applications. Copy if something's being copied to removable devices or copied to a network share, we can alert on that. Printing, we can block printing and things like that. So you can block with overrides, we can block it completely. Lots of different restrictions that we can put on where our data is going. And then setting that policy mode, good to always test it out first. Make sure, show the policy tips while in test mode so that the users are getting that, but also make sure that the information that we're getting, we're not getting a whole lot of false positives, and we can make sure that we can, if there's anything we have to change, we can certainly test that and make sure that, and like I said, and make sure that we are not being too stringent in our policies here, but also show those policy tips, because that hopefully will avoid some level of sharing. If somebody sees, a big alert when they go to create an email for a particular document, that might create a problem. So those are all things that we can continue to do here. I'm going to cancel out of that. I don't want to set this policy up myself. Some other things that we can do in here, in terms of within Purview, is the compliance manager. And if we want to create an assessment, we can come in here to create an assessment. We have a number of assessments in here, and we can, once it comes up, fun of live demos, we can select a regulation. So again, if I want to go, let's say GDPR, and do UK GDPR, we can set a assessment on a default group or an existing group, or we can create a new group, and it's going to look at Microsoft 365. I can add a new service in here if I wanted to, or select services that we've already done before, and select next and create that assessment. Now this is going to go out and look at any potential GDPR, look at our environment, look at GDPR under that environment and give recommendations. Very similar if you're familiar with Microsoft Defender for Cloud. It's going to give that assessment and tell us how we stand against compliance to GDPR in our current configuration. And that takes a while to do. We can't see it right away. You can see here, if I go to assessments or go to overview, it's going to give me it gives me a compliance score for for just a basic data protection level of assessment. This isn't, I use this for demos and for personal use, so I don't have a very good score. I could do a little bit better. You can see my points achieved versus and Microsoft managed points achieved. They're actually a little bit low on a couple themselves. That's the first time I've ever seen them not be 100% compliant on their own end. But our point, I've got some work to do. It tells me the work I have to do and what's going to do these make these points. And you can see, I have using anonymization to encrypt sensitive information. If I do that, I will get 54 points. So you can see lots of those in here. A couple of these, like having and applying a retention policy, I have as a failed test status. So so it's finding what I've got in my environment and what I can do to my specific environment as part of this assessment. Different data connectors here that we can connect to non-Microsoft data. If I look at my connectors, I don't know if I have any active. Give it a chance to load here. All right, let's skip that. But we go down here, we can connect to a lot of different, lot of software and information in here. Here's a LinkedIn company pages connector. So these are all things that we can connect to categorize that information and make sure it's in our Microsoft Purview Compliance Center. If it's apps that we have sanctioned and we want to use within our organization, we can test those as well. All right. So I will, that's it for what I wanted to demo. And just to kind of summarize, and then we can save some time for some questions. Again, knowing your data is the most important thing. And again, Microsoft Purview has the capabilities to go out and do some content exploration to find what kind of data we have out on our environment, our cloud environment. So once you know your data, where your sensitive data lies, then we can protect our data. We can do things to prevent data loss, and then ultimately our continuous improvement and continuous access is to increase our security posture through the governance of our data. Hopefully you've learned some strategies to secure and govern your data utilizing Microsoft Purview, including protecting data exposure, things to do to maintain compliance, understanding where your data is located and what data is sensitive. And then once you have all of that, you can govern over your data, what privacy laws you have to adhere to, what sovereignty around your information also goes into that as well. So that is everything. There is my social media links. Feel free to connect with me. I also do a learning I am a Learn expert for Microsoft Learning Hub. So I have a learning room around cybersecurity. Mine is mostly around security and protection with some compliance in there. There is also one that another MVP has that is around compliance and has a lot around Microsoft Purview as well. So feel free to go to this forum and you can connect to a bunch of Microsoft Learn rooms, and hope to see you there as well. Thank you.
So,
any questions there, Kevin?
No. So Dwayne, it was excellent. I haven't looked at DLP since my Microsoft Exchange days, and I'm seeing a lot of similarities to what we had with some of the early DLP integrations in there. So it's nice to see that Microsoft have made it nice and intuitive to kind of follow through if you've got that experience, or even if you don't, it's pretty straightforward once you understand what you're looking for, right?
And if you don't know exactly what you're looking for, at least you can put it in that test mode and test it out before you actually actually block somebody from access or something like that as well.
Exactly. No, it's really cool. There's no specific questions, Dwayne, that's come in on the chat. I guess that's kind of an indicator that, you explained it so well that nobody needs to ask any questions. That's typically how I roll.
So Dwayne, I have a question just for myself. So what are some of the use case in companies that will be able to use Microsoft Purview?
What is a particular use case? Is that what you said?
Yeah.
I mean, any company that has to that has any kind of sensitive information or any kind of PII or PHI. I mean, it really the nice thing about how Purview is licensed, if you're using any areas of Microsoft 365, 365 E3 or E5 licensing, you can get a level of the compliance manager. So if you have to have compliance, you can utilize the compliance manager aspect of Microsoft Purview to do compliance assessments and prepare yourself for an audit. Again, if you want to do areas of making sure that that you're not having data loss, or you want to create a policy that makes sure that your users aren't printing sensitive documents or utilizing USB devices to save documents to, you can create a DLP policy very easily to do that. And so it really, any use case that any company wants to get control of their data and get control of where their data resides, Microsoft Purview is very helpful for that.
Okay, so I take it that's why labels are very important in Purview, because of classification of what sort of information is per each.
Yeah, I mean, you can use like Purview for classifying particular types of data and building policies around that data, sensitivity policies, or if you have to have them as records for records management. But even so, just to have the rule, have the capability to make sure that your data is not leaking, that you're making sure that and keeping that zero trust around making sure where your data is and who's accessing it is a very key component to protecting your data and making sure that that you don't get yourself into a legal situation.
Yeah, sure, brilliant. So I've got a question come in. So it said, Janik, can you connect compliance state of data over Purview also with conditional access rules? I mean, you don't follow the rules of the company policy with your device, you can't authenticate?
Yes, that's a very good question, and one I probably didn't emphasize enough. There are connections to Defender for Cloud Apps as part of Purview, and then within Cloud Apps, you can use certain access rules or access policies or session policies into conditional access to require additional verification or block access to particular pieces of information if you don't have permission to. So yes, you can, utilizing Defender for Cloud Apps connection into Purview, and then the Cloud Apps connection into conditional access policies. So yes, you can do that.
Brilliant. Have you got any questions, Josh, Kevin, or Dwayne?
Yeah, I'll ask one actually. So, and again, even though I'm not kind of focused on that space, I'm doing a lot in other areas of Azure and currently dipping my toe with AI, which we had an AI session a couple of weeks ago on this show. So one thing I find really cool about solutions like this from Microsoft, and as a consultant, when I'm talking to my customers, I get these type of questions all the time. This is cool, but is it only for my Microsoft hosted workloads, for example, right? So I had a look before we came on live on air tonight. I had a look at some of the data connectors that Purview has and showed a particular interest for the non-Microsoft data connectors, right? So you mentioned you've got experience and certification in AWS. You'd expect the AWS stuff. I see that there's a Google connector, SAP. Dwayne, what's the weirdest or probably the the most out there data connector that you connected Purview instance to in the past?
I don't really have one. Like I said, I've been around AWS and Google, and even, you can pretty much anything, any operating system that you can put Azure Arc onto as well, is a data connect is another data connector that you can do, in terms of on premises as well. So it, like you said, it's pretty much anything that is going to have a level of access to data. You mentioned some like ERP type, like even like SAP. If you've got a SAP HANA database sitting on a server in your data center, if you put Azure Arc on it, you can connect that into Purview. So you got a very high level of flexibility, and it just keeps expanding more and more as as it continues to evolve.
Yeah, that's a good point about Arc. Actually, people tend to forget that Azure Arc can open up capabilities for all kinds of management and security platforms up in Azure.
Yeah, exactly. Yep.
Yeah, it's pretty cool.
Really expands the architecture and what you can do within the Microsoft environment to just kind of flatten your entire infrastructure really to one monitoring tool.
Right. Exactly. Yeah, it's pretty cool. Big fan of Azure Arc. I've no more questions. I think that was really good, and I'm just looking at the chat. We don't have any other questions since the last one from Yannick. Anyone else?
Yeah. Nope, no more question for me. Thank you, Dwayne.
Okay.
Thank you very much. I appreciate it.
Thanks, Dwayne. Appreciate the time. Okay, folks. So next up, we have Josh Duffey, who is a Microsoft advocate in Microsoft and working out of Nebraska, right, Josh?
That's correct. Yeah. Yep.
So you're going to talk to us today about another topic that is on my radar, as in I'm going to have to try at some point and get my head around AKS and deep dive into containers and stuff. And what you're going to do is talk about secure supply chain on AKS and some tools that I've never heard of. Trivy, Copacetic. I'm just
Copacetic. Yeah.
Oh, there you go. Right, notation and Ratify. So I'm really looking forward to this because when we're delivering our typical traditional Azure landing zone and Azure engagements, we use DevOps. But as I say to my customers all the time, I'm firmly on the ops side of DevOps. So I was dragged kicking and screaming into it, but I totally see the values and it's awesome. But it's I feel way out of my depth when I'm listening to sessions like from yourself or from Nicholas or some of the other MVPs that do that kind of deep dive level into DevOps and containers. So really looking forward to hearing what you have to say.
All right. Well, I guess we can kick it off. I've got a couple slides, not too many, to begin, and then we can kind of go from there. Let me get my monitor set up. Just 1 second. Share the entire screen. Let me know if you can see my desktop okay.
Yep.
Yep, coming in there now.
All right, now I need to switch. How's that?
Oh, good.
Good. All right. Let's see if I can move this around. I want to make sure I can get the chat. So if there's any, I'm pretty interruptible. So if there are any questions at any point, feel free to call my attention. I'll try to keep the chat window up to see if I can just bring those on. But yeah, just drop them into the screen and we'll go from there. So I've got a couple of slides, like I said, and then I've got a little demo that we could show off all these tools because you can kind of throw them all with the GitHub Actions and with Azure DevOps. It's nice to be able to shove all these tools into a workflow that's repeated and automated, but it's also really good sometimes to just break down, okay, what is this task doing? How does it connect together, and walking through it step by step? Because essentially, at the end of the day, a lot of the actions in a workflow, either with Azure DevOps, any of the CI/CD pipelines are really just chaining together command line tools that you can run interactively. And so that's what I'll do in the demo. But to get started, let's see if I can move that over here. To get started, what I'm going to talk about is securing container deployments on AKS, but I'm going to use open source tools. So all these tools that were mentioned previously that I'll talk about, they're all open source. Microsoft contributes to some of them. Some of them are maintained by Microsoft employees, but they are open source and they're not just features inside of Azure. So they're completely free that you can go and tinker with on your own. So a little bit about me. My name is Josh Duffey. You can find me on X at Josh Duffey, formerly Twitter. I'm a senior cloud advocate at Microsoft, have been for about a year. Before then, I was awarded the Microsoft MVP. So I only have one year of an MVP before I was beamed up to the mothership. And then I was an SRE at Stack Overflow. And so that's kind of my background. Again, I came from the traditionally the ops side. So Kevin, you said that you very much feel like you're on the ops side of the DevOps. I sit in a room constantly with people, and I always feel like I'm the operator. So I take it as a great compliment that I'm seen sometimes on the other side of that fence. But to kick this off, I want to start by talking about, actually referencing a talk from Kelsey Hightower. So Kelsey Hightower is probably most known for the Kubernetes space and advocating for that. So he was, at the time of retirement, I believe maybe a couple months ago, the beginning of this year, a distinguished engineer at Google. And again, a lot of his work was on Kubernetes, but he did start talking about secure supply chain just last year. And in his talk, he made this really good point. He told the story about, we have all this code, and what we do is we write the code, and we've got these packages up on GitHub, and we kind of just pull them in here. And so here's a simple Go application on the left side of the screen that's pulling in Gorilla Mux, which is a framework in Go to do web applications. And you just take that dependency and you pull it down from GitHub. And he posed the question, is that really so different than walking into a coffee shop and grabbing a USB key and plugging it in and being like, oh, this has all the packages that I need. I'm just going to plug this into my application. And so it started to make me think a little bit like, I would obviously never pick up a USB key that's just laying around a coffee shop and plug it in to my company issued device. But it's kind of the same thing with GitHub. There aren't a lot of controls in place, especially in the container space. That's still relatively new. And so what I'm going to talk about in this particular talk here is what are some tools and ways that we can make that a better experience with our container images, and securing the code would be a different talk. So to give you a high level, there's going to be two phases of the build process that I talk about, and one of them is build. And so this is from a DevOps engineer perspective. The developers have given you have a repository and you have some code, and you're now trying to build a pipeline to deliver that code out into the environment. And so what that looks like with containerized applications is they have the application code, you have a Docker file, or some way to create a container image, and then you're putting automation around that inside of a GitHub Action workflow or Azure DevOps. And then you're seeing that all the way through to being a container image that's deployed to a registry, and then that registry then is used to pull down images to your production Kubernetes clusters or whatever container orchestrator you're using. So on the left side of this process and this pipeline, there are a couple tools here that we can use. One of them is Trivy. Trivy is a vulnerability scanner, and that just lets you scan your container images for known vulnerabilities from a database of known CVEs, and that can give you a report. Now, the next tool is probably my favorite tool in this little bunch here, because Copacetic is an open source tool that can take that vulnerability report from Trivy and then use it to do OS level patching. So it takes your container image, it scans the report, and then it breaks it open and it starts to use apt-get or whatever your distribution is for a package manager and starts to patch the CVEs that were found in the report. And so by not even having to update the base of the container to a new version, you can ensure that your containers are being patched, at least from the OS level. OS patches are, I think, all that Trivy or Copacetic can do at this moment. But now that we've got this patched image, like how do we know that this code that we're pulling down, these images that we're pulling down are valid, that we trust them? Like, how do we make a signature on that? And that's where Notary, the Notary project, notation is the CLI. So you'll hear me probably use those terms interchangeably. If I say notary or notation, just know that they mean the same thing. They're part of the same project. Notation is just the CLI tool's name. So we can use that tool to create a digital signature on the image. And so that will put a signature artifact in a repository, and then that can be used to validate that we've signed off on this. We trust this particular thing to be our environment. And again, it kind of all begins and ends at the container registry. So we'd push the image up that was patched. It has a signature, and then we're eventually going to have to do something with that. And that's where the latter part of the process comes into play. So we'll just click through the animations here, and I can talk through it. So on the other end, we've got a container image up there. It's signed, but what's to enforce it? So if going back to the previous talk with the data loss prevention, if there's no warnings or no repercussions of doing that, if there's just going to be a flash, an error, or something like that, people are still going to do it. People are still going to deploy insecure images or vulnerable images to your environment if there's nothing on the other end to catch them. Just like with the data loss prevention. And so there's another open source tool that we can use called Ratify that sits on top of another tool called Gatekeeper. It's all abstracted, so you don't really have to care about that. But what Ratify allows you to do is install it on your AKS cluster, and then it will look every time you deploy a particular type of resource to Kubernetes, whether it be a pod or a deployment, and it will say, does the image in this manifest have a signature? And can I validate it? So you set up Ratify with a certificate that has the ability to look up the keys. And if it's not signed, if it doesn't have that artifact on the registry of a signature, Ratify is going to reject the deployment. And so that's a way to enforce the governance of, hey, in production or whatever environment, we are only going to accept signed images and then obviously reject unsigned. So that's kind of the end of the PowerPoint there. Let me pull up VS Code and we'll start the demo. So before I get started, just a quick sanity check. Is the font size okay?
Yeah, it's all good. You can see it.
Good deal. Well, I guess before we kick off the demo, let's just take a look around the repository so anybody can follow along. So this demo that I'm about to show you is meant to be part of a workshop. So if you're curious, like Kevin, you said you're curious, if you want to walk through all this on your own, you totally can. What I'll do is I'll just take a moment to walk through and familiarize yourself with this repository. So the name of it is Secure Supply Chain on AKS, just like the talk's title. And my goal here is to give you kind of a workshop to go through and set up everything I did. And everything in here is automated, coming from the infrastructure side, did a lot of infrastructure as code and automation. So naturally, I have some Terraform that sets up all the backend infrastructure that you need. I guess I won't go too much in that. You get a resource group, you get a cluster. There's some something called a workload identity that allows the cluster to talk to Key Vault. So then the Ratify pod can authenticate. If you're interested, you can pour through this. But there's the Terraform. If you want to follow along with the setup, there are a number of documents and then accompanying shell scripts. So if you really care how it's working, you want to tear it apart, go through the docs. If you just want it to run, there's a set of shell scripts I'll show you in a second. But the setup is here. So if you want to walk through, and I mean from zero, this whole document set here will bring you to where I am and walk you through the entire demo. So you can set up your Terraform through this. It tells you how to set up the Azure environment and then also deploy Ratify to the cluster. So all that is documented here. And then the workshop itself, which is the demo I'm going to walk through, is the workshop MD. So just kind of showing you around the repository. And then there's a bonus one, which will set up the workflow. But again, all of these are accompanied by shell scripts. So setup is here, and then demo, which accompanies to the workshop. So that's kind of the infrastructure and document set. There is an application in here. And so if we go into the source, this is actually the Azure voting app. Might have seen it. It's a very simple web app that has 2 voting options that you can change that connects to Postgres database to store the records. So it's just a really simple web app that you can use. My coworker, Paul rewrote it in Rust because he was learning Rust. So that's the source code. We'll be using that to build a container image. We need some kind of an application to deploy. So there's that. And then the shell scripts are in here, and you can just kind of take a look. The other thing to mention is I am using a dev container. And so if you're using Visual Studio, I've automated even the local development environment for you. So there are a lot of command line tools that you need, and they're all installed inside this install script. So a bunch of stuff. So there's a ton of stuff going on here, but I didn't want it to be just kind of like smoke and mirrors. It works on my machine. I went to a lot of great lengths to, if you want to repeat this and walk through everything and learn the things that I've learned, it's all automated in here, and you can kind of reverse engineer what I did. So now that you're somewhat familiar with what this application and this repository is, I'll go ahead and dive into the demo. So there is this pretty neat thing called demo script. I got this from a coworker, Steve Morawski, who borrowed it from Brendan Burns, and then Brendan Burns got it from another individual. But essentially what it is it's a utility script that lets me automate the demo, so I don't have to kind of go back and forth and run commands. So I'll just minimize all this and load it in, and we'll walk through it. So right now, what it's doing is I'm loading in all the environment variables. There's a bunch of Azure resource information that I need to have in my shell to be able to run these commands. For example, what is the Azure Container Registry instance name? What's the certificate name? And all of this will be printed out for you as you go through. But like I said before, this is a voting app that we have containerized. And so this all exists inside this Docker file. And what I'm doing is I'm just building the Docker file. If I minimize this, and so this is the Rust version of it. It's pulling at a pretty old, well, an older version of the Rust container. And so there's going to be quite a few vulnerabilities in here, which is relevant for later. But essentially just copying in the source and then building it, and then creating a multi-stage build that gives me a container that I can deploy the Azure voting app in. So I've built that, and now I have the container image locally on my my local machine here in my dev container. I also need a database because it's a 2-container deployment where I have the web app and then I have a database inside of a container. Whether that's a good approach is debatable. Maybe you should use a different managed service for the database, but it proves well in this demo. And then I'm just showing you, I've built my v0.1 alpha, and then I've pulled down version 15.0 using the Alpine distribution for Postgres. So now just to show off some of the tools that I talked about. So here's Trivy. It's going to go out and it's going to scan my local container image against the database that Trivy has for known CVEs. And if we scroll through here, there's going to be quite a lot. And it's all just kind of in the terminal. So we can use some different arguments of the command line tool to limit us. Maybe we only care about the critical. So you can actually use Trivy as part of your build process instead of outputting the CSV or the JSON file with the CSVs in it, or the patches that need to have the vulnerabilities. There we go. That's where I was looking for. You can actually have it throw an exit code. So if your container image has any vulnerabilities of a certain severity or any severity, you can change the exit code and have it kill the build process. The way that I'm demonstrating it is I'm not having Trivy throw an error and stop the build process. I'm simply using it to get a list of the vulnerabilities and then passing that to the next tool, which is Copacetic, that you'll see here soon. But as you saw, now I'm only getting back the critical. So the dash severity, and then you can just list one of the severities that was listed there. I think there's critical, high, medium, and low. And then you can filter the results of the scanner. So another way you can do it is you can filter by the type. I mentioned earlier that Copacetic really can only do operating system level vulnerabilities. There might be other types of vulnerabilities in here. And so we can filter down the results even further by using the vuln type argument. And then in this example here, I'm telling it not to exit with one. So if it finds a vulnerability, typically what it'll do is it will throw exit code 1. But instead of putting it out to the terminal, I'm going to have it output to this patch.json in the root directory of my repository. I'm only going to use the vulnerability scanner. Trivy can also do configuration scanning. So maybe my Terraform configurations are using secrets in an inappropriate way, or I'm just using interpolation incorrectly. Trivy can also detect some of those configuration changes or misconfigurations, but I'm not worried about that. I'm only worried about the vulnerabilities, in particular the OS vulnerabilities. And I want to ignore unfixed, because if it's unfixed, then Copacetic isn't going to have a fix for it. I might as well just ignore it in my output. And then at the very end, that's the name of the image that I'm scanning, which I'm sure you caught on to above. And so now I can cat this and just take a look at the vulnerabilities and sort by the ID and grab out what's unique. So here are just the number of vulnerabilities from an OS perspective that Trivy found. And so now what I need to do, and this is a limitation of Copacetic currently, is I can't scan with Copacetic the image locally. It needs to be on a remote registry. And I believe that's because of its original design. So Copacetic was originally designed by the container upstream team inside Microsoft, and they were charged with managing all these container images floating out on the registries, and they needed a way to scan them. And so their use case was, the images are already on the registry, so I need to scan them. I think in the future it'll likely, because of this new use case where you can put it into your pipeline, it will allow you to scan locally. But for now, it does have to exist on a remote registry. So there's a little bit of a back and forth. And so what I'm doing is I'm going to tag the Azure Voting App Alpha with my registry. So I have a container registry that I want to host this image on. Currently, it's only local, but I need to push it to ACR in order to have Copacetic patch it. So I'll go ahead and push that up to the repository. And Nicholas and Nick, or Kevin, if you have any questions, even during this, feel free to pop back on the camera, and more than happy to pause the demo and answer any questions or just chat about the different tools, even if you think they're cool.
It's cool. All good though. No questions coming in at the moment.
Yeah.
Good deal. All right. I'll keep on going. So now I've got my Azure Voting App, the web app portion of it, on my ACR. Now I can patch it. So again, Copacetic is just a CLI tool, and I'm pointing it to, we'll let that run a little bit. Maybe it'll stop. There we go. So I'm giving it the image. That's what the -I is. So this is the image on the remote repository. The records that I'm passing in is the patch.json. And then I'm giving it a new name. So this is a pattern that the upstream team came up with, which was still semantic versionly compliant. So it'll still be valid semantic version, but it's to append a hyphen and then a count at the end of the container name, just to show that you've patched it. You can, if you want, you can just override the existing tag. So I could just patch v0.1 alpha and then use that tag moving forward. But if you wanted to have some way of indicating that this is a patched image, you can append the -1 like I've done here. So now what will happen in the next series of commands, after Copacetic broke open my container and started to patch all of the packages that it could based on the results from Trivy, I'm going to have a new image locally. And so I'm going to scan that for vulnerabilities locally, and hopefully it'll be reduced. I think there were 14 critical. If we looked up above, there were 14 vulnerabilities found in the first version of the container image, and now there's only one. So there was only one critical that Copacetic couldn't yet patch. And hopefully that would be remediated soon. But I also have 2 images now, and I have to push the patched version to the registry so I can use it in my deployment. And that's the kind of the back and forth that I was talking about, where it's a little bit, there's some rework in there, some redundant steps where it would be a lot better if I could just patch this locally, but just a limitation of the tool currently, you have to have it in the remote registry and then push it back up.
Josh,
Yeah.
I got a question just for myself. Why is that fixed version empty? Does it mean there's no version to get it fixed? Natwick tool on?
I just don't think that feature's up on their list currently, because their use case is, I have a ton of images on a registry and I want to patch them. What I'm doing is taking that tool and I'm putting it into the developer's workflow, so that way patched images are just on the registry, and you kind of negate the need to scan the registry constantly for patches. Where I'm trying to put patch versions on the registry, where they're kind of like a platform team that a bunch of developers are just pushing images to, not patching them, and they're responsible for ensuring that they're patched. So
okay, I guess you can probably automate this using GitHub Actions, right? Like,
yeah,
put
so
it
I
as
could
a schedule,
totally,
whatever is in the morning or stuff, afternoon, just scan some images in your ACR.
That would be the other use case for Copacetic. So right now I've got it shimmed into my build process. So I'm making sure that the first image I put on the registry is patched. The other use case is, you could put a cron job on your workflow and say, every hour or maybe once a day at midnight, I'm going to go through all the images in my registry and I'm going to patch them and then increment their tag. Or you could just override it. You don't have to put the patch increment counter at the end. That just tells you how many times it was patched. If that's valuable to you, you can use it, but you'll also have a timestamp on the layers, because when you push the image back up, another layer is added to the digest changes of the container image. And so you could use that timestamp to say, when was the last patch job run? So yeah, there's the two use cases for Copacetic. Good question. Good question. Thank you. Sorry, I have like two big monitors, so whenever I'm talking to somebody, I look like I'm, like turning. But anyway, good stuff. All right, so now I'm going to tag the Alpine, because I also need, if I'm going to deploy this to my AKS cluster, I need to have a version of the Postgres image in my ACR, because I'm not allowing my AKS cluster to just pull from Docker Hub. I want to pull from my known registry. But to recap, I now have an unpatched version, a patched version of the web app, and now I'm pushing up a version of the database, the Postgres database that's going to be part of the Azure voting app. And now I'm happy. I want to be able to use and trust the patched version of the container image and then the Postgres one that I pulled in. And so what the demo walkthrough is setting up Notation. So Notation is a digital signing CLI tool. And what I'm doing, that already exists, so disregard that. But what I'm doing here is I'm adding a key. So there's a plugin for Notation that connects to Key Vault. So the certificate, the digital signing certificate, exists on Key Vault. It could exist in a number of different places, but I'm using Key Vault. And so I'm adding this certificate ID so it knows which certificate in the Key Vault to use for digital signing. And there is a particular way that you need to set up your signing certificates. It needs to be really restricted in the amount of things that it can do and its key usage. And so if you're curious about what those settings are, you can open up the Terraform and see how I'm creating the key in that. I just got an error because I already ran through this just to make sure things worked. It already exists, so I have my key there. I'm going to list it, so it's going to list all the keys. You might have a local signing key, you might have one in Key Vault, you might have a different key per environment, most likely, and so you need to add them to your runner or whatever you're using to sign the images. Now, here's a really important piece of information that's different when you're using signatures versus just using container images. So before I used any kind of signing, I've always used the tag. I've always used the Docker image tag, and I didn't even know you could use the digest. So what the digest is it's a unique number that's assigned to each layer, and it will never be the same. Using I think a SHA, a 256 SHA, and it tags each layer of a container will be completely unique. And you want to use the digest as the signature for an image and not the tag. So if I have this version 01 alpha -1, that tag has the SHA of this value here. Now, the reason I want to use the SHA and not the tag is I can just rerun Docker build with a new base layer or a base image, or pull in some more code and re-push to that tag because it's mutable and the tag won't change. But everything inside of the container and the layers that make up the container did change. So if I can sign the tag, but then if I do, there's a trust issue because I can no longer guarantee that what I signed in that tag hasn't been overwritten somehow. And so what you want to do instead is you want to sign the digest. So I just use the docker inspect command to return back the digest. And then I'll use notation to reference the image like this. So to reference a digest, you have to put at instead of the colons, and then SHA-256 followed by whatever that digest ID that was returned back. And you get that digest ID when you push to your registry, when you're doing your Docker build commands. That's when it gives you that information. You can also pull it retroactively with the inspect command like I did. But if you want to have complete assurance that the digest that you're grabbing is the right one, you want to grab it from whatever command you use to build or push the Docker image. And so that's right there. So if you use Docker inspect, I also have to get it for the Postgres image. And now I can sign both of those images because I need to sign the web app that I built. It's my container, but I'm also taking a dependency and using Postgres. And I want to use that internally and not rely on Docker Hub. And I also want to make sure that I've signed off and I sign this because I could use Trivy and Copacetic to patch the Postgres image too. I just didn't in this demo for time. So now I've successfully signed both of these images. And we'll take a minute just to look at what happened inside of the Azure portal. So if we come into here, you'll actually be able to see the artifact. There's a number of CLI tools that you could use to get this information too, but sometimes the GUI is just easier for simple things. So if we come in here, we should now see that we have this signature artifact in here. And that references this particular SHA. And so if we come in here and go into refers, we can see that it has an artifact that's referring to it as CNCF notary signature. And so that's our signature artifact that Ratify is going to look for when it goes to admit containers or deployments to the cluster. So we'll go back to the demo. And I'll show you that it should, yeah, here we go. So it failed to deploy the manifest. So if you look in here, here are all my deployment artifacts in manifests. So I have the constraint, and we'll get to that in a second. But the main thing is this deployment app and deployment DB, and then I have a service sitting on top of that in Ingress, so the whole application works. But I'm pulling this local image here, and that's not signed. Now, because I've got kubectl installed and I've got Docker on my local machine, it should be able to grab this image, but it's saying that it could not get the signature. And so what Ratify is returning is I'm going to reject this deployment because I cannot verify the signature of the application. So what I'll do is I'll use some fancy sed commands to modify the image that's being used inside of the deployment. And I'm going to replace it with the image that is on ACR. And I'm going to use the digest as a reference. Now, it's important to know in your deployment, it'd be easier to have the tag in here. And you can, just as long as you don't overwrite it, because Notary and Ratify are going to look at the digest. But you can still use the container tag inside of your deployment scripts, inside your Kubernetes deployment manifests. So just to show that that worked, I've now replaced the image with the image name in SHA that has the digest after it. And I'll do the same for the database deployment. And we can open that too. And so there's the updated image pulling from ACR. And now I'll redeploy it. And so it didn't get rejected by the admission controller, that admission controller being Ratify. And if I wanted to, go ahead.
Sorry, Josh. One more question. You know that when you get the error message when you run it, do you and it give you when you sign it? Does all the SHA values that long, or you can just make it smaller, the SHA value within YAML?
That's that long. Yeah. So you have to reference it that way. That's what I was saying is I could come in here and I could use this tag v1.
Yeah.
Which is totally fine. I could probably even update the demo to do that. What would happen though is if I pushed another layer to this same tag, the signature is going to fail. So you're going to have to make sure that you re-sign the tag again. Because it's gonna use a new digest.
Okay, so every time you got new image, you get new digest, you need to sign it as well.
Yep. Because that's how I ensure what I signed is what I'm actually deploying. Otherwise, if I just use the tag and I override it because the tag's mutable, it's just a kind of a guess, a hope that it's the same or safe image that I signed previously. Yep.
I guess you just want to keep the image integrity and just make everything, make sure it's the same image.
Yes. Yeah. All about image integrity. Yep.
Yeah.
Very good. Good question. So now that the app is deployed, let's see if the pods are running. And then I think I have take a look at the Ratify logs right here. Copy this command. So I was able to deploy my app in my database. If I were to run git service, I'd see that too. So let's just open up a new shell and look at the Ratify logs. And let's see if we can find the success message. I need to just remove the grep. My grep skills are weak, I will admit. Here we go. So here's the line where it went to go and pull the certificate for the Postgres. And this is what Ratify is looking for. Did this validation succeed? So if this was false, that's where to get rejected. Since it's true, here's the verifier report of all the certificate information that came from that digital signing cert that's in Key Vault now, that was part of the Terraform buildup. So it was able to verify the certificate is valid, the signature is valid, it let it on the cluster. So now we see our pods. Here's the constraint. So I have a constraint on here. So all API groups that have the kind of deployment that are in the default namespace. So I could change, if I only want production to have the admission controller with Ratify and rejecting things, I can scope this to namespaces. I can also change the different types of resources that I want to constrain. Now, I'm mainly worried about container images, but Ratify is in the works of being able to validate SBOMs. So if your application doesn't come with a software bill of material, then it can reject that too. And so that might be another kind that it would reject, or type of resource that it would look for. And if we look at the manifest, the template, this is what actually is all the logic for the policy that Ratify is looking for. I won't pretend to understand all of this, but essentially this is the logic in here for the policy that's doing the verification. This is a bit of a gray area for me that I need to dive more into myself. But those are the two pieces. You have to put Ratify on the cluster and then deploy a template and a constraint. And that's what actually makes the admission controller work, so to speak. So if we wanted to, we can test and make sure that the web app deployed so it's not all smoke and mirrors. And I can vote for dogs and cats. Again, like I said, super simple app. But really, you don't need anything really crazy to tinker with a lot of these tools and to build a bunch of stuff on top of Kubernetes. Again, like my background's more operations, and so building the apps is a little bit more of a struggle for me. But then once I have something to deploy onto a cluster, I kind of can get my feet underneath me, so to speak. But that's really it for the demo. If you want to know how the workflow works, there is a doc that walks you through it called Bonus. And then there's also the workflow files that you'll get. So essentially all this does is takes all of those commands and uses the GitHub action versions of them to put them in a workflow. And then I can run these instead of having to do all this manually, because that was a lot of work. I have to scan it, I have to patch it, I have to sign it, and And it seems like a lot of work until you automate it, and then it just happens on its own, And so what that would look like, if we go to the repo, here's build, push, deploy. I think this is a good one. This is, high level overview. I'm signing into my registry, or logging to Azure, my registry, and building my container image. I'm scanning it, patching it, pushing the image up there, signing it, and I'm on my way. But to Nicholas's point before, I do have another workflow in here that I'm working on that does the other end of it. Let's say I have images on a repository and I want to patch them. How do I do that? And so I have a workflow in here called patch.yaml, and that's mainly using Copacetic to find images on a registry. This is be way more typical of a scenario for someone in an ops team. Developers are pushing images. I want to make sure they're secure. How can I use Copacetic to patch them and then return back to the developer a patched image? So at least I'm that much more secure. That's what this patch.yaml is. So yeah, I'll go ahead and stop sharing and open up for questions and answers. Potential answers. Can't promise anything.
Sorry, just trying to come on. That was brilliant, and really, really good as well to hear that you've come from that ops side as well, Josh, because you spoke like a boss there. But it's really interesting. It's still, most of it's gone over my head if I'm being honest, right? But it was you explained it really well, and the add-on tools like the Copacetic and the Ratify, I mean, it makes perfect sense to use them in that kind of chain, so you can kind of lint your workloads, right? So I'm familiar with linting in DevOps pipelines for the code, but I suppose this is a deeper level on it now. So
just more stuff to add to the pipeline. That's all it is.
Yeah. Just keep stacking up that pipeline. Yeah. And your GitHub, I think we'll share the GitHub. I know you had it in a session, but we'll share your GitHub as well, because that's some really good resources.
Please do. Thank you.
Yeah.
We've got a question from Wes. I'm not sure if I pronounce it correct. Copacetic look great for scanning registry with the pipeline integration scenario. What is the benefit of using Copacetic over bumping base images to more secure versions?
So the big scenario is you have an upstream dependency on some kind of a container image that isn't doing any of the patching. And so, and maybe you're locked to a particular version of that container image. Copacetic lets you patch them as they are at that current version without having to manipulate the base layer. So that's a benefit there. The other one would be to make sure that you're introducing the most secure version of that image at the build time. So those would be the two scenarios. It's like you have a dependency on them, then they're not changing. I saw a meme on Twitter the other day, or X the other day, that kind of captured this, like the upstream dependency, they won't update it. There's no new base image version to go to. And there's a CVE. What do I do? That's where Copacetic comes into play.
Okay, brilliant.
And any more questions from the chat, folks? I don't see any, but there's your chance, folks. Anyone that's online, pop a question in.
So if you have like ACL with like maybe 50 images, how long does it take to scan all that? Is it a few minutes?
The Rust one had a lot of things in it, and that took like a couple minutes. It's rather fast.
Okay,
but I guess I could go back to the upstream team, because they scan thousands. Like how long do your jobs run would be a good question. But it all,
so it's not based on the size of the image, right? You just
the number of vulnerabilities. So how many times does Copacetic need to run an individual apt-get lines to patch is more, and how big are those patches, and how long does it take to update the app? Yeah.
Okay, nice. Good.
So no more questions come in on the chat.
No more question. Have you got any questions, Dwayne, for Josh?
No, I'm good. My voice is leaving.
I'm good.
Yeah, it's quite cool. It's well like layout as well, so I can't wait to play with it.
Well, thank you. I appreciate it.
Good.
Yeah, any feedback? I'm still learning this stuff myself. Like now I'm on this kick to dive into like what exactly is a container and like what Linux features is it using? Like how is Docker doing this? Because there's a lot of stuff in. I mentioned the SBOM, the software bill of material. So another thing that you could do with the SBOM is replace the Trivy scan with the SBOM, and then that would have all the information in there, and so you could pass that along. And so instead of needing to rely on the information that's in the container. So an example of where this breaks down is say that you're using some kind of container image upstream and they're using from scratch. And so what from scratch does is it blows away the file system and just leaves the binary. But when you do that, then you wipe out all the metadata of the packages in the operating system. And then Trivy will give you inaccurate results where your image is more vulnerable than it says it is because you've wiped out the file system on the top layer, but underneath it still has that. And so you can use the SBOM to capture all of that information and then throw that to your scanner and get appropriate or correct and accurate vulnerability reports. And so, but all that requires like, how's the container feeding this in? And so that's my big deep dive currently is just figuring out all those bits and pieces. Yeah.
Would you normally run any like unit tests and stuff with it, or just run it on its own, like those tools?
Well, you would probably have those inside your application build. So a unit test would be somewhere in that workflow to test the actual Rust code and stuff like that. But
okay, yeah. So got no more question here, and
no more. I think we're
I love it. So I love both of them. So Dwayne, I kind of learned some preview from you and Josh.
Thank you.
Yeah, thanks very much.
Thank you both and everybody for having me.
No worries. Anytime. So let me play a little 10-second outro video and then we can. Okay. So that's the next episode. Sorry, that's kind of new.
Very cool.
Okay. Thank you so much for your time. Really appreciate it. Have a great day over stateside, and we'll get ready for bed over there.
Yes, good evening to both of you. Yes, thank you.
Cheers, lads. Bye-bye.
Cheers.
Bye.